You are welcome once again. This is Solomon at Solo for Math. Feel free to subscribe to our channel for more lessons that are coming online every day. So today it's an extension of the first lesson that we had about logarithms, and today we want to look at examples to apply the laws that we covered about logarithms. If you didn't watch the laws, check in the videos. I'm going to put the link in the description so you can check and you follow up. Alright, so I have a few questions here that I want us to go through. Number one, show that 2 log of 4 plus half log of 25 minus log of 20 is equal to 2 log of 2. Now, someone is wondering, where is the base? The base is not appearing here. But whenever numbers, logarithms are written like this, the base is what we call the common base. And the common base, we take it to be base 10. So there is base 10 here. Okay, so we can handle it without even the base. It is known, but we are working in base 10. Okay, so we are going to apply a few laws. First of all, whenever we have a number appearing before the logarithm, we have to take it and it powers this. Okay, the argument, it has to power the argument. Even here we take it up and then we continue. So we are going to show from the left hand side that it is equal to the right hand side. So from the left hand side, 2 log 4 plus a half log 25 minus log 20 is equal to, right, we put the 2 up, so it will be log 4 squared plus log, put the half up, 25 to power half, then minus log 20. So we simplify this, and when you work out this, it will give you 16 plus log, when we have a number to power half, that is like the square root of that number, which we shall see that is a 5. Let's first simplify that. 16 plus log 5 minus log 20. Now here we bring in the law about addition of logarithms and subtraction. Using board mass, we start with addition. Addition. So when we consider addition, we said if the base is the same, we know it is 10. Then we multiply the argument with the same base. So we have log 16 times 5 base 10. Sorry, let me leave it there, don't mind. Log 20. So this would give us log, this is 80 minus log 20. Now when we finally consider this subtraction, we said when we are subtracting 2 logarithms with the same base, what we do, we divide the argument. So meaning this would be log the same base, but we divide this. Alright, so when we divide, it will give us log, it was 80 over 20, dividing this, we'll go with that by 2, 1 by 2, 4, so remain with log 4. So we want to show that it is exactly equal to what they want. So what we do, express this 4 as a power of 2, 2 to the power 2, so we can bring the 2 down. It is still under the law the laws we looked at. Yeah, and we've clearly shown that the left hand side is equal to the right hand side. Okay, another question here is express 7 log 2 SA minus 3 log 12 base A plus 5 log 3 base A as a single logarithm. As a single logarithm. So how do you do this? Anyway, it is just applying the laws of logarithms about addition and subtraction. So we have 7 log 2 base A minus 3 log 12 base A plus 5 log 3 base A. This would be equal to, I don't have enough space here, let me write it here. To be equal to, you have to write it on this side. To be equal to, we said first thing, take away these coefficients here. Okay, so when we take them up to give us log 2 to the power 7 base A minus 3, log 12 to the power 3 base A plus log 3 to the power 5 base A. So what do we do? Use body mass, start from addition. So we shall start by adding this and this, and when we add, we say the base, if the base is the same, then we multiply the argument. So meaning this would give us log 2 to the power 7 times 3 to the power 5 base A, then we bring in the minus log 12 to the power 3 base A. And now we have subtraction. I may wait to work out these. Now when we have subtraction, the base is the same, then we divide the argument. So we have log 2 to the power 7 times 3 to the power 5 over 12 to the power 3 base A. When you simplify this, when you simplify it, you end up with log 18 base A, and we've expressed it as a single logarithm. That is what was expected of you in such a question. Now let's look at another one. Find the value of x. The value of x. So let's first look at this, where we have log 3 log 4 base 2 equals to x. To work out this, what we are going to do is we are going to just change this base, this argument, and write it as a power of 2. So that power of 2 will go down, and we remember that somewhere we said that log of if we have the argument the same as the base, then that gives us a 1. So we shall say x is equal to 3 log of 2 squared base 2. So this 3 can come, the 2 comes down, so times 2 log of 2 base 2. But we said, remember that log of 2 equals to 1. As long as this argument is the same as the base, then we shall have a 1. So this one gives us a 6 times a 1, which gives you 6. Okay, and that is it. Then part B, I have 4 log of 2 base x equals to 0.5. So here we have an unknown base. Always when we have an unknown base, we are required to first change it to a known base. But since we've not looked at changing of base, we can change it to index notation. This is logarithmic notation. Change it to index notation, then we can be able to get the value of x, I guess. So for example, of course, we first take this side so that we have log 2 power 4 base x equals to 0.5. Now we said to change to index notation, the base remains the same. Bring this to power. The exponent should power here 0.5. Okay, and then the argument drops down, so we have 2 to power a4. Alright, now we know this is x to power half equals to 2 to power 4. We could just square both sides. 2 to power 4, square both sides. This will give us x because these 2 will go with this, so remain with x equals to 2 to power, that is 8, because when you have this power out, it's the same as multiplying with this, so you have 2 to power 8, which is something like 256. So that is how you can use logarithms, or you can solve for x using logarithms. We shall look at other numbers when we start about change of base in our next lesson. But for now, let's look at maybe the last example. Given that log 2 equals 0.3, show that log 5 equals to 0.7. So how can we show that? Alright, so we want to show this, so we are going to start from the left hand side. So we have log of 5 equaling to log 10 over 2. We are just trying to find an expression that has log 2 because it's what is given, it's what is known. Then we use it to get this. So when we use the laws of logarithms, when the argument is a quotient, then we can distribute it or separate them into individual logarithms with the same base, like we have base 10 there. Then we subtract log 2 base 10. But we know when the argument is the same as the base, then the log is 1 minus log 2, we have it already as 0.3. So this gives us 0.7 as required. Thank you for watching. If you have any question, please kindly write it in the comment section, and share, like, and subscribe to my channel, and also click the bell for the subsequent lessons that are coming online. Thank you.